This is Note Taking Guide 6.5 for Math 1. So today we're going to continue in our geometry unit. We're going to start talking today about some angles and some vocabulary of angles so that we can solve some different kinds of geometry problems with angles. So the first thing I want to do is go over some vocabulary with you, and I want to remind you of the definitions of some of these things. So supplementary angles mean that you have angles that add up to 180 degrees. Supplementary means exactly that. So I want to remind you that anytime you have a straight line like this, a straight line adds up to 180 degrees, which means if I had an angle that cut that straight line into pieces, these two pieces would be supplementary. They would also add up to 180 degrees together. So supplementary means add up to 180 degrees. Complementary means that they add up to 90 degrees. So a lot of the time they will be in like a 90-degree angle like this, and then you'll have two angles inside there, and those two angles will have to add up to 90 degrees. They don't have to be attached in order to do that though, so you can just randomly have two different angles that would add up to be 90 degrees. It's really just any set of angles that add up to be 90 degrees. The next one is something we call vertical angles. Well, vertical angles are formed when we have two lines or line segments that intersect each other. When that happens, we form sets of angles. So we form a set of angles here with a set of angles here. That set of angles right there, they're vertical angles. These two angles would be equal to each other because vertical angles are equal to each other. The same thing happens the opposite direction. Another set of vertical angles is formed. So this direction right here, a set of vertical angles is formed, and those vertical angles would also be equal to each other. So really what vertical angles are angles that are opposite or across from each other when a cross is formed with two lines. Alright, the next vocabulary is angle bisector. An angle bisector, it does exactly what it says it's going to. If you have an angle and you have a bisector, that bisector cuts the angle into two equal pieces. So this side over here would have to be equal to this side. They're equal to each other. That's what an angle bisector is. Alright, now let's just remind ourselves what our angles are according to their names. So the first one that's on here is acute. Acute is less than 90 degrees, which really means it's, small, acute. Right is exactly 90 degrees. So it looks like that. Obtuse is more than 90 degrees. So it's like this, really far open. And straight is just like this. A straight angle measures 180 degrees. Then opposite rays are like this. You have one ray going this direction, an opposite ray going this direction, and it really can form a straight line, which means they're going to also be adding up to 180 degrees. Opposite rays don't necessarily have to be touching each other because they're rays, but they still would form a straight line together because they're opposite of each other and add up to 180 degrees or be supplementary. All right, now we have our vocabulary down. I think we can get started. So this first example says BA, which is a ray, and BC, which is also a ray, are opposite rays. Solve for DBC. So we're looking for DBC, so the measure of this angle right here. Well, because these two rays are opposite rays, so this ray and this ray are opposite of each other, we know that those two rays add up to 180 degrees. So if I have 180 degrees, and I already know that 114 of it is being used, then I can just subtract those numbers and find my measure of my other angle. So 180 minus 114 gives me 66. So this angle right here that we were looking for is going to be 66 degrees. All right, the next one says find the measure of BCA. So we're finding from B to C to A. So we're looking for this one right here. Now, how are we going to find that when both of these angles have x's in them? Well, we're going to use what we know. We actually know, if we're looking at this, that this big angle is a right angle. We know that the two pieces of this right angle are going to add up to 90 degrees. So what I'm going to do is I'm going to add those together and set them equal to 90 degrees. I'm going to add them the way that they are. So I'm going to start with the x and the 3x and add that together to be 4x. I'm going to take the plus 12 and the minus 6 and add those together to be plus 6. Then I know that's going to be equal to 90, so I'm just going to set it equal to 90 and solve it. I'm going to minus the 6 to the other side to start isolating that 4x. When I do that, I get 84. Then to isolate x further, get it by itself, I'm going to divide by 4 because it was multiplied by 4. When I do that, I get x equals 21. Now, it makes me think I'm done because I got my x value there, but I'm not actually done because the question didn't ask me for x. It asked me for angle BCA. So I actually have to substitute that x value back into the value of angle BCA, which is 3x minus 6. So I have to go 3 times 21 minus 6 in order to find the value of that angle. So just punch that in your calculator, 3 times 21 minus 6. And when I do that, I get 57 degrees for the measure of the angle. Which makes sense because 57 is less than 90, so that could be a possible answer. And it is. So that's how I do that problem. All right, let's go take a look at the next one. The next one, problem C says find angle 2. Oh, this is going to be a piece of cake because guess what we formed right here when we found those two lines that intersect each other? We found a set of vertical angles. And if you remember the rule for vertical angles, these angles that are formed from opposite of each other, they're actually equal to each other. So if this angle over here is 68 degrees, then this angle over here has to be 68 degrees. That's the rule of vertical angles. All right, problem D. If AT bisects BAN, so this one is a bisector of BAN. Okay, that's awesome to know because what we know now is that this piece over here on the angle is equal to this piece over here because angle bisectors cut angles into two equal pieces. So really now, if they're equal to each other, I can take this angle and set it equal to this angle. So I can go 6x equals 2x plus 32. Then I just need to solve that equation for x so that I can substitute it back in to find my angle measure. So my first goal is to isolate the x's. I'm going to get them all by themselves. So I'm going to subtract this 2x over to the other side. So I have 6x minus 2x, which is 4x. Over here it cancels, which is what I wanted it to do, and I get equal to 32. The next thing I do to isolate that x is divide both sides by 4. I get x equals 8 for my solution for x. But it doesn't answer my question. I'm actually looking for angle TAB. So I'm looking for this angle over here from T to A to B. So I got to substitute it back into that 6x. So 6 times x would be 6 times 8. 6 times 8 is 48. So my solution for this angle is 48 degrees. Now, interestingly enough, I know this one is also 48 degrees because I know that they're equal to each other. All right, I think we have one last problem to do on this note-taking guide. So, two in the last problem. It says, classify each angle as acute, obtuse, right, or straight. Then use your protractor to measure each angle to the nearest degree. All right, I don't have a protractor on this iPad at all. I can't use one. So you're going to have to do that part in class. But let's decide what kind of angles they are. So we're looking from E to F to D. So from E, F, D. So what kind of angle is that? Well, that's clearly smaller than 90 degrees, which makes that an acute angle. So when you measure that on your protractor, it's going to be less than 90 degrees. All right, the next one we're looking for is AFD, so from A to F to D. All right, this angle right here, that's an obtuse angle because that's greater than 90 degrees. And again, when you do your protractor measuring on your own, that should be bigger than 90 degrees for your measurement. All right, you guys, thanks for listening to me today. I appreciate you spending time. If you have any questions, please make sure you come and see me. I'm always happy to help. Good luck on your homework.